All right, in this tutorial, we're going to go over exponents with integer bases. So the first thing that we need to discuss is the difference between an exponent and a base. So right now we have an expression that when you read it out loud is a raised to the b power or a to the b power. The small number that's written above and to the right of the big number is called the exponent. So in this specific expression, the b would be considered your exponent. It's the number it's actually called a superscript. It's smaller and it's written above the other numbers or other terms. Then the number underneath or the term underneath is going to be called the base. So in this specific example, a would be considered your base. Now these two numbers interact with each other in a way where the exponent is going to tell you to multiply the base by itself that number of times. So back to this one, the b tells you how many times you're actually multiplying, and then the a is the thing that is being multiplied by itself. If we put it more of in a context of numbers, 4 to the third power, or 4 cubed, is the same thing as saying 4 times 4 times 4. And you see there are 3 of those things being multiplied together. And then when you multiply all those things together, you end up getting the number 64. So that's what the exponent tells you to do, is just multiply the base that number of times itself. Now, zero exponents interact with the base a little bit differently. I'm going to go ahead and leave this blank for now, and we're just going to kind of investigate this pattern that's going to happen when you decrease your exponents until you get to 0. So for example, 2 to the third power, 2 times 2 times 2. We know that 2 times 2 is 4, and if you multiply 4 times 2, you get 8. 2 squared, or 2 raised to the second power, you multiply it times itself twice. 2 times 2 is 4. And then 2 to the 1 power just means that it's written once, which really it's not technically a multiplication problem. It just tells you that your base is only written once, and that is still 2. Now the pattern that needs to be recognized when going from each of these numbers sequentially decreasing in order to go from 8 to 4 and 4 to 2, the same pattern that you're going to go to get to each number is dividing each of those by 2. And the reason why it's specifically 2 is because all of our bases are written in 2. If I redid this exact same pattern with 10, you would be dividing by 10. If I did the pattern with 6, you would be dividing each number by 6. Now, if we continue that pattern, again, dividing this number by 2, we are going to get the number 1. 2 divided by 2 is 1. And this pattern is going to work with every single base that is raised to the 0 power or has a 0 exponent. So anything that raised to the 0 power is always going to be equal to 1, no matter what. Positives, negatives, fractions, irrational numbers, rational numbers, anything to the 0 power is going to be equal to 1. Now, a couple examples in order to evaluate. 3 raised to the 5th power is the same thing as saying 3 times 3 5 times. We know that 3 times 3 is 9, and we're going to do that again with the second one. And then we're going to multiply that thing times 3. We know that 9 times 9 is 81. And then when we multiply 81 times 3, 243. You just need to simplify that all the way down as much as possible. Or if you're able to just simply type this into a calculator and you're able to manipulate it with the exponents, that's also going to give you the same thing. But it's important to realize that the exponent, the 5, is what tells you how many times you multiply that thing times itself. Now, likewise, going backwards, we need to figure out a number that can be plugged into the exponent that when you multiply the base times itself that many times, you're going to get 100,000. So let's just start plugging in numbers. If we multiply 10 times 10, or 10 squared, that's going to give us 100. That's not enough. Now let's try it 3 times. 10 times 10 is 100, and then we multiply that times 10 again. We get 1,000. That's still not enough. What about 4 times? Well, we know that each of these is 100, and if you multiply 100 times 100, you get 10,000. Still not enough. But if you look at the pattern, each one of these things, you're adding a 0 to the end. So when powers of 10 are being raised to a certain exponent, 2 corresponds directly with the number of zeros in your answer. So 10 to the third means that there are 3 zeros. 10 to the fourth means that there are 4 zeros. So if you count here, 1, 2, 3, 4, 5, means that we need to get 10 to the fifth to get 100,000, which is 5 zeros. So our answer W equals 5.